I still remember the sound my neighbor's 2001 F-150 made when it hit a deer at 55 miles an hour on Highway 61. The bumper bent. It didn't crack, didn't shatter, didn't split down the middle like something made of pressed sawdust and glue. It bent, and we bent it back with a come-along and a tree trunk, and he drove it home. That bumper cost him nothing. The repair bill on my brother's 2012 Silverado after the same kind of impact, $2,400, and the truck still sits crooked because the plastic components underneath absorbed energy the way God never intended plastic to absorb anything. That bumper is gone now, not just from Ford trucks, from all of them. And the reason it disappeared is the same reason most of the things I want to talk about today disappeared. Because somewhere in a boardroom 30 years ago, someone figured out that it costs less to build a truck that falls apart in a specific way than it costs to build one that lasts. If you're new here, my name is Wade Tucker. I've been turning wrenches on pickup trucks since 1984, and I started this channel because the people who profit from you not knowing how to fix your own truck have gotten very good at keeping you ignorant. Everything I tell you comes from what I've physically seen, what I've physically fixed, and what I've watched fail in ways that didn't have to happen. Hit that subscribe button before you watch another video by someone who's never turned a bolt in their life and is just reading a press release. Now the comment section at the end. Before I get into the 10 features, I want to hear from you. Which truck feature do you miss the most? Tell me in the comments. I read every single one. Let's start with number 10, bench seats in full-size crew cab trucks. I'm going to say that again because I know some of you are too young to have lived it. Bench seats in crew cabs. Full-size trucks used to come with a solid steel bench that spanned the entire width of the cab, with enough room for 3 adults across if you needed it. I drove a 1997 F-150 XLT with the 5.8-liter V8, crew cab, long bed, and that bench seat for 6 years. I hauled feed bags, lumber, people, dogs, and one time a full-size freezer lying on its back because the tailgate was down and the bed was long enough. The seat didn't care. It was built like a tank and it sat you like a tank. By 2004, Ford had quietly eliminated the bench from the F-150 crew cab. Chevrolet followed around the same time. Ram hung on a little longer, but by 2010 it was gone from all 3 major American manufacturers. What replaced it? Bucket seats with a center console. Now I want to be fair here. Bucket seats are more comfortable for the driver. They offer better lateral support. They're nicer to sit in on a long haul. I understand all of that. But here's what they took from you. The bench seat was bolt-in, steel-framed, and could be removed in 20 minutes by one person. You could pull it out and carry a water heater across the cab if you needed to. The bucket seats weigh twice as much, are wired into side airbags, and require a mechanic to disconnect the seatbelt pretensioner before you can even slide them out of the truck. When my brother's 2012 Silverado needed the driver's seat frame replaced because the recliner mechanism stripped out at 140,000 miles, the OEM replacement seat cost $1,100. A rebuilt bench seat for a 1997 F-150? $85 at a junkyard. The seatbelt pretensioner system alone in a modern truck adds $400 to that repair, and it's a part that fails more often than anyone in the industry will admit. Now, number 9, carburetor-era engines that run without a computer. I'm not going to stand here and tell you that fuel injection is worse than a carburetor. It isn't. On a dyno, on an emissions test, on a fuel economy chart, fuel injection wins. But here's what nobody talks about. A carbureted engine will run if you can turn a wrench. You flood it, you choke it. You foul a plug, you gap a new one and put it back. You want to tune it, you adjust the mixture screws with a flathead screwdriver while you listen to the engine. There is no scanner, no laptop, no proprietary software, no firmware update, no sensor calibration that requires a dealer visit. I rebuilt the 5.8-liter Windsor in my 1995 F-350 with nothing more than a Chilton manual, a set of basic hand tools, and a timing light that cost $30 at a pawn shop. The last carbureted American pickup was a 1990 model year. By 1991, fuel injection had taken over across the board. And yes, fuel injection is more efficient, but the computer that runs it is also the computer that decides your truck needs a new fuel injector assembly because the idle is rough. And that diagnostic fee at a dealership to read that code? $125 just to plug in the laptop. The fuel injector assembly itself, if the dealer decides you need it, try $1,800. I've seen a rough idle on a 1996 F-150 with a 5-liter V8 that turned out to be a dirty throttle position sensor. Cost of the sensor, installed if you do it yourself, $23. Cost to have a shop diagnose it and install it, $450. That's not the sensor failing. That's the system requiring a trained technician to interface with the trained technician's laptop. Number 8. Dealer serviceable transfer cases. Now, if you don't wheel your truck, you might think this one doesn't apply to you, but it does, and here's why. A transfer case on a 4-wheel drive pickup is what splits power between the front and rear axles when you engage 4-wheel drive. On a 1999 Chevrolet K1500, the NP246 transfer case was the standard unit, and if you needed to service it, you opened the drain plug, drained the fluid, unbolted the inspection cover on the side, and you were inside the gears. You could rebuild it with a gasket set that cost $19 and a socket set. The bearings, if they were worn, cost $32 each from Napa. Total rebuild cost, if you did it yourself, under $200, including fluids. By 2006, most manufacturers had moved to sealed electronic transfer cases. The 2007 Silverado with the AutoTrack system uses a Borg-Warner 442 transfer case that is completely sealed. There is no drain plug. There is no inspection cover. If the clutch's inside slip or the encoder motor fails, your only option is to replace the entire unit. The remanufactured exchange unit from the dealer runs $1,900. The labor to install it, if you're not doing it yourself, runs another $600 to $800. And here's what really frosts me. The encoder motor on that sealed unit is a plastic component driven by a small electric motor, and it is one of the most failure-prone parts on late-model GM 4-wheel drive systems. I've replaced more of those encoder motors than I can count, and every single time the customer needed a tow because the truck was stuck in 2-wheel drive on a mud road where they shouldn't have been in the first place. But that's a different video. Number 7, removable and replaceable headliner panels. If you've ever owned a truck from the 1990s, you know exactly what I'm talking about. The headliner in a 1994 F-150 Super Cab was a cardboard back panel covered in fabric, held in place by a series of plastic clips around the perimeter and 2 bolts near the rear view mirror. It took about 15 minutes to remove, and a replacement from a junkyard cost $15. If it got stained, if it sagged, if a fishing rod poked through it on a long haul, you pulled it out, you replaced it, or you recovered it, and you were back on the road. The headliner in a modern crew cab is a molded composite panel that is adhesively bonded to a structural reinforcement framework built into the roof. It is not bolted in, it is not clipped, it is glued. And when it starts to sag, which they all do within 15 to 20 years because the adhesive degrades, your only option is a full replacement that requires removing the windshield, the A-pillar trim, the sun visors, the dome light assembly, and the overhead console if your truck has one. A new OEM headliner for a 2015 F-150 runs $800. The labor to install it, at a shop that charges $100 an hour, runs another 6 to 8 hours of work. That's $1,700 to fix a headliner that a 1994 F-150 owner would have handled with $15 and a Saturday morning. And here's the part that really gets me. They sag because the manufacturers switched from a mechanically fastened clip system to adhesive to reduce assembly cost at the factory by about $4 per truck. $4. That's what your $1,700 repair bill is protecting. Number 4, hydraulic power steering replaced by electric power steering. This is the one that nobody talks about, and it's the one that has changed the driving experience of a pickup truck more than almost anything else I can think of. Hydraulic power steering uses a belt-driven pump that pressurizes hydraulic fluid and sends it to a rack and pinion assembly through a set of high-pressure lines. The system provides what engineers call steering feel, which is the feedback you get through the steering wheel when the tires are fighting terrain, when you're driving on aggregate asphalt, when you're turning and the front end is loaded. That feedback is communication. It tells you what the front wheels are doing. It tells you when you're about to lose traction. It tells you when you're turning and the weight of the engine is loading and unloading on the suspension in a way that affects your line. Electric power steering, which became standard on most half-ton pickups by 2008, uses an electric motor mounted on the steering column or the rack to provide assist. There is no belt-driven pump, no hydraulic fluid, no high-pressure lines. It is quieter, it reduces parasitic drag on the engine, and it makes it easier to implement lane-keeping assist and parking assist features. Those are real advantages. But here is the disadvantage that the manufacturers don't advertise. Electric power steering systems fail in ways that hydraulic systems never did. A hydraulic power steering pump might leak, might whine, might occasionally require a new reservoir or a new line. Those are all repairable. An electric power steering motor, when it fails, does so without warning, and the failure mode is typically a sudden loss of assist while you're moving. I have pulled into parking lots and had the steering wheel lock up on me twice with electric systems. Both times at low speed, thank God, and both times required the truck to be towed. A 2013 Chevrolet Silverado I worked on came into the shop with complete electric power steering failure, and the cause was a failed torque angle sensor in the column motor assembly. That sensor is part of the motor housing and is not sold separately. The complete column assembly, including the motor and the sensor, ran $1,420 from the dealer. Hydraulic power steering rack and pinion for a 1999 Silverado, $160 at a junkyard, installed by me in 3 hours. Number 3, solid front axles on half-ton trucks. Now we're getting into the serious off-road durability conversation, and this is one where I will take the position that what was removed was genuinely better for a working truck. A solid front axle, sometimes called a live axle or a beam axle, is an axle design where the differential and the axle housings are a single unit that moves as one assembly. The wheels are connected by CV joints on the axle shafts, but the differential, the ring gear, the pinion gear, all of it moves up and down with the wheel travel. This is an older design. It was used on pickup trucks from the 1930s through the 1990s. It is still used on 3/4 and 1-ton trucks today because it is extraordinarily strong. It can handle enormous torque loads. It can handle far more suspension travel than an independent front suspension. And critically, for anyone who uses their truck for real work or real off-roading, it is virtually indestructible under conditions that will tear apart an independent front suspension. The Ford F-150 went to an independent front suspension in 1997. Chevrolet went to an IFS design in 1999. The independent front suspension offered a smoother ride on pavement, which is real, but it introduced a series of failure points that had not existed with the solid axle. Upper and lower control arms with ball joints, sway bar end links that corrode and break, CV axle shafts that wear out faster because they have to transmit power through angles that a solid axle never required, rack and pinion steering that replaced the steering box on the frame rail, which was a much more durable design. I've rebuilt more independent front suspensions than I can count. I've replaced ball joints at $120 each. I've replaced CV axles at $240 each. I've replaced tie rod ends. I've replaced pitman arms. I've replaced idler arms. Every one of those parts is a recurring maintenance item that did not exist on the solid axle trucks. The 1997 F-150 with the solid front axle that I drove for 12 years needed exactly 0 front end work in the first 200,000 miles. The 2004 F-150 I owned after that needed upper ball joints replaced at 95,000 miles and lower control arm bushings at 130,000 miles. Both repairs were necessary and both were expensive. Number 2, mechanical fuel injection. I know I mentioned fuel injection earlier in the context of computer-controlled engines, but mechanical fuel injection deserves its own place on this list because it sits at a very specific point in automotive history that most people skip over. Mechanical fuel injection, specifically the Bosch K-Jetronic system used on the 1970s and early 1980s fuel-injected pickups, and the throttle body injection systems used through the late 1980s, was fuel injection without a computer. The K-Jetronic used a mechanical fuel distributor driven by the camshaft that metered fuel based on the amount of air flowing into the engine. There were no O2 sensors, no mass airflow sensors, no throttle position sensors, no manifold absolute pressure sensors. There were no DTC codes. There were no check engine lights. If your K-Jetronic system wasn't working, you had a mechanical problem. A clogged injector, a failed cold start valve, a leaky fuel accumulator, a bad fuel pressure regulator. Every one of those parts was mechanical, visual, and diagnosable by listening and looking. I have fixed K-Jetronic systems with a screwdriver, a wrench set, and a can of carburetor cleaner. By the early 1990s, the EPA mandated electronic fuel injection on all new vehicles, and mechanical fuel injection vanished entirely. Electronic fuel injection is objectively better for emissions, for fuel economy, and for performance. I will not argue with that. But the complete electronic control of fuel delivery introduced the dependency on the PCM, the Powertrain Control Module, which is a computer that runs the show. And once you have a PCM, you have sensor networks. And once you have sensor networks, you have a whole new category of failures that are electrical rather than mechanical. And those failures require diagnostic equipment to find. A mechanic can hear a lifter tick. A mechanic cannot see a failing O2 sensor that is reporting false lean conditions to the PCM and causing the engine to run rough under load. I've had trucks come into my shop where the owner was convinced the engine was burning oil because it was running rough, and the actual cause was a failed mass airflow sensor. Cost of the sensor, $140. Cost of the diagnostic labor to find it if you're taking it to a shop, $175 just to plug in the scanner and clear the code. Number 1, full frame steel bumpers. I've saved this for last because it is the one that I think best represents everything that has been lost in the transition from working trucks to market segment trucks. The full frame steel bumper on a pickup from the 1980s and 1990s was a piece of structural steel, usually either chrome or black powder coat, that was bolted directly to the frame rails of the truck. It was not a crash crumple zone. It was not an energy-absorbing structure. It was a solid bar of metal whose entire purpose was to protect the truck's body and frame in an impact. It worked. The 1997 Ford F-150 bumper, part number F67Z-17757-BCAP, was a steel stamping that weighed about 32 pounds. It attached to the frame with 6 grade 8 bolts. When it was damaged in an impact, you unbolted it, you took it to a body shop, and if the damage was minor, you hammer-dented it back and had it re-chromed or recoated. If the damage was major, you ordered a new one for $85 and bolted it on. Total cost of repair if you did the work yourself, $85 in 1 hour. The bumper on a 2018 Ford F-150 is a complex molded composite assembly that is part of the front fascia design. It is not bolted to the frame. It is part of a trim assembly that is designed to look integrated with the body. When that assembly is damaged, you don't replace a bumper. You replace the entire front fascia, which includes the bumper, the grille opening, the lower air dam, and the fog light housings if your truck is so equipped. The complete front fascia assembly for a 2018 F-150 Lariat runs $2,200 from the dealer. Even from a wrecking yard, an undamaged front fascia is hard to find because they're all damaged on every truck that comes in. And here's the part that really matters. The composite bumper is designed to crush in an impact to protect the occupants of the vehicle in a crash test. That's a real safety benefit. I don't dispute that. But in a low-speed parking lot impact, the composite bumper absorbs energy by fracturing, and it does not protect the frame rails, the radiator support, or the hood structure the way a steel bumper does. So you get a lower insurance claim on a crash test dummy, but you get a much higher repair bill on the actual truck. I want to make one thing clear before I wrap this up, because I know someone in the comments is going to say I'm just being nostalgic. I'm not saying old trucks were perfect. The 1997 F-150 with the 4.6-liter modular V8 had a timing chain guide problem that would leave you stranded if you didn't maintain it. The 1999 Chevrolet Silverado with the 5.3-liter V8 had AFM, the active fuel management system, that was a nightmare on early models. Those are real. I've documented them. But those are engine problems, and engine problems are diagnosable and repairable. The problems I'm talking about today are different. They are problems that were designed into the truck for economic reasons, not engineering reasons, and they result in repairs that cost the owner money they didn't have to spend before. Full-frame steel bumpers disappeared because composite fascias are cheaper to manufacture, and allow for sleeker aerodynamic styling that helps fuel economy numbers on a test cycle. Sealed transfer cases appeared because it costs less to assemble a sealed unit than to machine and assemble a serviceable one with drain plugs and inspection covers. Electric power steering became standard because it eliminates the belt-driven hydraulic pump, which reduces engine drag and helps meet corporate average fuel economy standards. None of these decisions were made because engineers woke up one morning and decided to build worse trucks. They were made because CAFE standards, liability law, crash safety regulations, and manufacturing economics created an environment where a truck that costs less to build and can be sold for a higher price while costing less to warranty is a better business decision than a truck that lasts forever. And that is the point. It's not a conspiracy, it's economics. Simpler parts mean lower manufacturing cost. Complexity means higher repair costs at the dealer. A truck that you can fix yourself is a truck that doesn't generate ongoing revenue for the service department. A truck that requires a $200 diagnostic scan to find a failing sensor is a truck that generates revenue every time something goes wrong. I'm not saying there's a man in a room rubbing his hands together. I'm saying the incentives in the system point in one direction, and that direction is not toward the truck owner's interest. Which truck feature do you miss the most? Tell me in the comments. I read every single one. Hit subscribe if you want more content like this, and hit the bell if you want to see it when I post. I'll see you next time.